So we are going to take a look at what we've studied so far in 8th grade. And so I'm going to do this by breaking my sheet of paper into 4 sections. So if I'm breaking my paper into 4 sections, what should you do?
Break your paper into 4 different
Okay.
sections.
All right. Now, what was the first type of relationship we studied this year? Linear, okay. And for those of you at home, this is kind of a call and response game. So unmute yourself. I want to hear your voice, okay? Don't wait to be called on, just shout it out. Adam is like, this is the best thing ever. All right, so we have linear.
No, it's not.
No, it's not? Oh, come on. What was the second type of relationship that we talked about?
Exponential.
Exponential is not the second. It was the third.
Inverse.
Inverse. All right.
Oh, yeah.
And then as you guys have pointed out, exponential.
And then quadratic.
And then quadratic. So these are, so far we've studied 4 different types of relationships, and we're going to go through all 4 types of relationships. Now, functions can be represented in 3 different ways. We can represent them as a equation, which is what we're working towards. That's what we really want in algebra. But we can also represent them in a graph or in a table. So we're going to talk about all 3 representations. That's a really cool looking bottle. I like that. So all 3 types of relationships in table, graph, and equation form. And since equations are really what we're after nowadays, let's talk about linear equations. Equations will be orange. All right. What does an equation, a linear equation look like?
Y equals x plus b.
Y equals mx plus b.
There you go, y equals mx.
Standard form is
Hold on. And what form is y equals mx plus b?
Slope intercept.
Okay. And m is the slope. B is the y-intercept. All right. Now, I heard some of you say that there is another form that we talked about. Standard form. All right. And standard form is ax plus by is equal to c. And a, b, and c are integers. And a has to be positive, a plus. Now there is a third type of relationship that we did talk about briefly, maybe for 2 days, way back in September. What is it called? Point slope form. Point slope form is written y minus y1 is equal to m times x minus x1, where the slope is still m. That makes sense, right? And our point is x1 comma y1. So this is really helpful if you know the slope and a point, because you just plug in the point into the equation, you plug in the m into the equation. Congratulations. It's a good
what's the thing called again?
This is called point slope form. All right, those of you at home, are you doing okay so far? I was like, heck yeah. Chase is playing with his pen. Would you like a new pen, sir? Okay. All right. So the next thing that we talk about a lot are graphs. So what does a graph of a line look like?
A very straight line.
A very
It's straight direct.
okay. So I'm gonna graph 4 different lines, and then we're gonna talk briefly about the 4 different lines. All right. So let's say we have this line here. The y-intercept is occurring where the line crosses the y-axis. The slope, just like the warm-up, is rise over run. And the slope for this graph is negative. All right, so if I were to graph this line here, same idea with the y-intercept. What kind of slope is this? Positive slope. I swear that yellow burns my eyes. It is pretty horrible
Why did you use it?
because my eyeballs needed to be damaged a bit. All right, so then we also have horizontal lines. What kind of slope does a horizontal line have? It does have one. It is 0. It is 0. And 0 is an acceptable number for a slope. We're allowed to have a slope of 0, so it has a slope of 0. Incidentally, this equation is going to be written as y equals and then whatever number that y-intercept is. Because the slope of 0 and y equals mx plus b, 0 times x, it eliminates the x, because 0 times anything is 0. All right, and then we also have vertical lines. What is the slope of a vertical line? This is the one that has no slope, that's right. Because you can't, so the run in this case is 0. It doesn't move over on the x-axis. And you can't divide by 0. So that's why this has no slope. Are linear relationships functions? Yes, linear relationships are functions with one exception, and that one exception is this vertical line. The vertical line fails the vertical line test, which is how we figure out whether something is a function or not. And so we would write this vertical line as x equals and whatever number this is. So more or less, linear relationships are functions. For a table, use red. For a table, okay, if I'm looking at a linear table, the change in the y values is referred to as the rise. In this case, this is 6. You're right, the change in the x value is called the run. In this case, it's 2. When x is equal to 0, just like the warm-up, that is called the? It's the y-intercept.
You skipped over 1 on the x side. Just go 0, 2, 3, and then 4.
Oh, sorry. That's going to mess up my video a bit, isn't it? Thank you for noticing that, Morgan. That's helpful. All right. And so what is the equation of this line?
6
2x plus 4.
Okay, so y equals, and what's the slope again?
The slope is 6 over 2.
6 over 2, which is?
3.
Emerson, you can shout out too if you want, which is 3. What is my y-intercept?
4.
4. Now we talked briefly about slope being rise over run. There's one other piece to this whole slope puzzle that that I know we talked about. You may remember it from last year as well. I don't know. We'll find out. I'm trying to shrink this, but it doesn't want to be caught. All right. Like this. All right. So slope, little niche there. Slope m is equal to rise over run. But if we're given 2 points, and asked to find the equation of the line, we have to be able to take those 2 points and find the slope.
Oh.
So slope can also be written as y2 minus y1 divided by x2 minus x1.
Doesn't that have a different name? My sister was telling me about that in her geometry class this year. She called it something else.
That's the slope equation. Yeah. Now I know we talked about it this year. You remember that? You remember seeing it? Yeah. And so using my little purple niche here. So if we have 2 points, we have x1 comma y1, and we have x2 comma y2. And you just plug in the points into your equation. Okay? All right. We really need to start moving faster. So that's a note to myself. All right, for inverse relationships, back to the orange, what does the equation of an inverse relationship look like?
Y equals K.
Y equals K over X. Y equals K over X. Where K is a constant. In other words, it's a number that will not change. There's another way to write this inverse relationship. Yes, Isaiah?
K equals Y.
No?
Is Y?
K equals Y times X. Or XY. So in other words, when I multiply my X and my Y values together, I will always get the same value. Always. So in its graphic form, I don't want that color. I want this color. You will have a curve that never touches either of the axes. Is in our inverse relationships or inverse variations functions? Do they pass the vertical line test?
Yes. No.
No, they do not, because a vertical line will not touch the graph at the y-axis.
So they're not functions.
This is not a function. This is definitely not a function. Now, later in high school, they'll teach you a way to get around that not a function piece, but I'm not going to worry about that now. Just know that they will do that eventually, and it's okay. And finally, for our tables, you will not have a y-intercept, and this is a common one that you will see. Notice that when you multiply x times y, you always get the same number. 1 times 24 is? 2 times 12? 3 times 8? 4 times 6? 5 times, no. You get the idea, right? Okay. What is the equation of this table?
Y equals 24 divided by
Or x times y equals 24. Either one would be fine. C or no? C. And I don't know. Okay. Exponential relationships. All right. Does anyone remember what the equation of an exponential relationship looks like?
something like some.
Thank you for raising your hand. And I know I did say call and response, so you did everything I asked you to do. Nate?
I'm not sure if it's right, but I think it's y equals times b's to the x power, or
That is exactly how you write it, yes. That is exactly right. Somebody from home. What does A stand for?
The y-intercept.
There you go, y-intercept. What does B stand for?
Growth factor.
The growth factor or
The K factor.
the decay factor. Now your growth factor has to be greater than 0. Your decay factor is greater than 1. Your decay factor has to be less than 1. And you cannot have a negative growth or decay factor. That would just not make sense. For our graphs, I'm going to draw 2 little graphs here. Doesn't like drawing on the bottom of the board. All right. I think it's punishment for not being small. I'm not big either, right? So our graph comes in 2 different varieties. You have exponential growth, which looks like the early days of the coronavirus. Yeah. Yay! And then we have decay, which looks a lot like inverse variations, with one really notable exception.
As an x-intercept.
It has a y-intercept. It has a y-intercept. That's a big notable difference. Now, for our table, let's go with this. I keep wanting to skip numbers in the x values number. All right. What is my A value for this table?
2.
2. Because it's the y-intercept. What am I multiplying by every time?
3.
So we have 2 times 3 to the power of x. And that would be our equation. Sure you don't want another pen? Okay. Other questions so far? All right. Now, we also spent a lot of time talking about the rules of exponents, didn't we? Yeah, we did. So let's talk about some of those exponential rules that we talked about. So we had, it's funny listening to Mrs. Stoddard talk about when they're passing out vaccines for the Spanish flu in the 1920s. Almost a first-hand account, but not quite. All right, so the first rule that we had, why are you laughing? First rule that we had was a times to the x power times a to the y power. In other words, we're multiplying 2 numbers with the same base together. In this case, what are we going to do with the exponents?
Add them.
We're going to add them. So it's a to the x plus y power. The next rule we talked about was taking a monomial to another power. So a to the x to the y power, what are we going to do with the exponents?
Multiply them. Multiply.
The next most common rule of exponent that we have talked about is when you're dividing monomials with the same base. So if we have a to the x power divided by a to the y power, what are we going to do here?
Subtract.
Subtract the exponents. So we have a to the x minus y power. And then we also talked about negative exponents, a to the negative x. Do negative exponents give us negative numbers? No, they give us decimals or fractions. So we would create a fraction with 1 in the numerator, and then the denominator will simply be our a value to the positive exponent. Finally, when something is taken to the 0 power, it'll always be equal to 1.
1.
So there's our exponential rules. Whew. Now, when we talk CMass, these 3 relationships could be on it. Most likely linear. On CMass, you should be thinking linear, linear, linear. Or linear or not linear. You will definitely be asked to say what is linear and what is not. If something has if an equation has exponents, it's probably not linear. Or if it has no y-intercept. But sometimes they'll try to hide the y-intercept by not showing it in the table, but you can still work backwards to get it just like the one. Yes, that is true. All right, talking about CMass. Now, we're not going to talk about quadratics so much. That is definitely not going to be on CMass whatsoever. Because a 8th grader at 8th grade level should have mastered linear, inverse, and exponential relationships. Some of you will have mastered quadratics, some of you will not have. That is not an 8th grade expectation. Okay? However, transformations are an 8th grade expectation. And we've talked about transformations as well. Can anyone give me the name of one type of transformation? I gotta call Logan because he's totally not paying attention. What is one type of translation or transformation? It's amazing. I even gave you an answer. Molly's laughing at that. So there are 4 different things that make up transformations. Can you give me one of them? Yeah, okay. Can anyone help us out? Isaiah? Translation, which is what I said when I said.
Yeah, I remember.
Logan, if the teacher is writing, should you be writing as well? Yes, the answer is simply yes. Okay. Hey, what's another way of thinking about a translation? What will happen to a figure if we have a translation?
It will, move.
Will it rotate? Will it
No,
flip?
it
Will
won't.
it slide?
Yeah,
Will it get bigger?
Slide.
This is going to slide.
Slide. Move.
Will translations create congruent figures?
Yes.
Yes, they will. What about rotations?
It rotates.
It will rotate. So a translation is going to come in the form of x plus or minus a number, comma, y plus or minus a number. A rotation is going to have a point, most likely for you guys 0, 0, a point that it's going to rotate around, and a degree measurement. And a direction, clockwise or counterclockwise. Will rotations give you a congruent figure?
Yes.
Yes, it will be congruent. Same size, same shape. That's congruent. All right, what's another form of transformation?
It's dilation.
A dilation, okay. I'm gonna put this down here. is saying what happens in a
It
dilation?
gets bigger, or it's
Bigger or smaller?
It gets bigger or smaller. Will a dilation make a congruent figure?
No.
No, but it will be similar. So you'll have scale factor and stuff. And a dilation has to have a center of dilation. That's the point that the things get bigger or smaller from. And it has to have a scale factor, a dilation factor. What is the one that we're missing?
Reflection.
Reflections. Maybe a little right, maybe not.
It reflects across the actual y-axis.
Now reflection, most of the time in 8th grade it will be over the x or y axis, but it could be any line with any equation that we choose. And so a reflection is, essentially we're flipping it. Does a reflection create a congruent figure?
Yes.
Yes. Same size, same shape. Same size, same shape. So these all create congruent figures. Dilations are the only ones that are not congruent. Whew! Other than quadratics, we just went through everything we've done in 8th grade so far. I hope you found this to be a helpful review of what is expected so far. Now, when it comes to CMAS, there's one other piece of linear relationships that's a huge part of CMAS, and that's our next unit. Okay, so we'll still get the pleasure of that unit, and this is pretty much what's going to be in CMAS. Yes, Isaiah?
Do we need to include these in our unit folder?
This goes in your unit folder, absolutely. All right, at home, do you guys have any questions?